Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a third problem on how to figure out what the K value is of your target equation based on using the relationships between K and some other equation that you're given. So it's important to know what the relationships are between K and a chemical equation and how changing one affects the other, how changing your chemical equation in some way affects how you change your K. So, for example, if you reverse the equation, then that means that the K value, the equilibrium constant of the new equation, is going to be the reciprocal of the K of the old equation, the original one before you reversed it. Also, if you multiply your equation by a factor, then the new K value of the new equation is going to be the old or original K value raised to the power of the factor that you multiplied by. So let's get into this. So here we have our equation. This is what they're giving us. So 2CO, COF2 gas is in equilibrium with carbon dioxide gas and CF4, carbon tetrafluoride. So here they're giving us the equilibrium constant for this reaction. And now they're giving us this our target here, and we want to know what the equilibrium constant is for this reaction. So we need to look at the one they're giving us to work with and see how these two are related and how you can manipulate the given equation to get this one. Anything you do to manipulate this equation causes you to do something to the K value, and that's going to help you determine what the new K prime value is. So this means K prime, that little line there. Okay, so how do we do this? First thing we want to notice here is where the reactants and products are. So here we see that we have here a reactant COF2, and then here we find it as a product, COF2 as a product. Here it's a reactant. Here we see that CO2 and CF4 are reactants, and here we see that they are products. So this equation that we are trying to look for, trying to determine the K for, is the reverse of the reaction that we're given here. So that means that this K value, this K prime, is going to be equal to the reciprocal of this K. So meaning that K prime is going to be equal to 1 over K. So that's because we reversed it. So if you reverse the reaction, then the reaction that you get after you reverse it has a K value that is the reciprocal of the original K value. Now that we got that done, let's take a look at what else we can see that's related to this equation here, or different from this equation. So the other thing I see is that here our CO2 and CF4 only have a 1 coefficient. Here they have a 2. Here the COF2 has a 2 coefficient. Here has a 4. So it's obvious that this equation this equation I should say, was multiplied by a factor of 2 to get this equation after we flipped it. So we flipped it, but not only did we flip it, we multiplied by a factor of 2. So what does that mean? Again, as I said before, if you multiply your equation by a factor of 2, then you have to then raise your raise your equilibrium constant by a factor, raised to a power of 2. So whatever you multiply by, the factor you multiplied by becomes the coefficient of becomes the power of the equilibrium constant. Sorry, I'm getting all this mixed up. So since I multiplied this equation by 2 to get this equation, so that means that I have to raise my everything to the power of 2. Okay, so now all I have to do is plug in k that I have here. So then our new k is going to be equal to 1 over 2.2 times 10 to the 6th power, and all of that is squared. So now all I have to do is plug that into my calculator and figure out what the answer is. And when I do that, I get our new k prime is equal to 2.066 times 10 to the negative 13 power. Let me double check that. That is correct. So this is my new k value. That's my k prime. So this is the equilibrium constant for this reaction here. So that's it for this video. I hope you enjoyed this video. I hope this was helpful in helping you figure out how to determine what your K value of a certain reaction that you're given, a target reaction, when you're given the K values of other reactions that you can kind of manipulate to get to your equation. So if this was helpful, then by all means, please like the video, share this video with your friends. Make sure you hit that like button, and also make sure you subscribe to my channel, hit that notification bell. Make sure you click all when you do so you can get all the notifications for all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.